Hi everyone. Section 2.2 is all about elementary functions. Now, what I've posted on Blackboard for you is just a summary of all the functions that you're going to look at in your 1324 class for right now. And they are the linear function, absolute value, um, quadratic, square root, cubic, cube root, and then transformations on these basic functions, the parent function and the transformations. Now, what is last on his agenda today is going to be piecewise functions, and I think that's where we'll do our focus. Um, and then if you have any questions about the others, then we can of course go over that as well. But this is in there for you, and he will have notes on it as well. Okay. But what I want us to talk about is first of all is inequalities in interval notation. Okay. Of course, we know what the basic inequality symbols are. Less than, greater than, less than or equal, greater than or equal. What do they really mean, and how can we interpret that into a graph? Okay, so I'm going to start with um, looking at inequality notation, the accompanying graph, and interval notation. Now, interval notation, it will take and go from the smallest value to the largest. And it will look like an ordered pair, kind of. So again, we'll show you how that equates to this inequality. Of course, this inequality symbol means x is greater than a. So x is greater than some value a. Okay. So you're going to have a value a on your graph. Everything greater than a is to the right. And what we need to do is to be able to show that it is strictly greater than a. That means it does not include a. It has to be bigger than a. And in order to do that, we put a parentheses. In interval notation, we're going to go from the smallest to the largest value. Well, the smallest value is a. The largest value, this goes on forever and ever and ever, so our largest value is going to be infinity. Since we did not include a, it gets a parentheses. Infinity is an idea. You cannot have an actual number that is infinity, so it is going to also be a parentheses. Now, contrasting that with this symbol, x is greater than or equal to a, we have that x is greater than or equal to a. So that means, of course, if you've got a on your number line, it's going to be everything to the right of that, everything larger than that. But to show that it includes the a, instead of a parentheses, we're going to have a bracket. Excuse me. Okay, so our smallest value is a, our largest value is infinity. We're going to put a bracket at the a, and infinity always gets a parentheses. The symbol pointing this direction means that x is less than a. So again, I'm going to have a on my number line. All of the values that are smaller than a are to the left. So now a is our largest value. This goes on forever and ever and ever until you get to negative infinity. Again, that's an idea, not a number. So your smallest value is going to be negative a, negative infinity. It always gets a parentheses. And since a is not included, it gets a parentheses. This, of course, means x is less than or equal to A. So I have, oh, and that gets a parentheses there. So I have my A value. Less than is everything to the left. But to show that I'm including the A, I'm going to put a bracket, which means my smallest value is negative infinity. My largest value is A. It includes the A, so I put a bracket there. Now these four notations, notice you have a value on the left and the right, a smallest and a largest. So this is going to represent between. So we know for all of these, A is the smallest value, B is the largest. And now we just need to figure out from the symbols whether we use parentheses or brackets. So if we go from A to B, everything in between there, if you have less than, it does not include the A, so it's a parentheses. Less than B, you do not include the parentheses. Or include B, so you get a parentheses. So it is everything between. And this is really a combination of the inequality x is greater than A and x is less than B. Okay, so for our next one, again, we have an A and a B. It's everything in between. But here we are including the A. It has the less than or equal. We are not including the B. So in interval notation, it would go from A with a bracket to B with a parentheses. Our next one, of course, we're going to be between A and B. A is not included, so it gets a parentheses. B is included, so B gets a bracket. And for our last one, we have A and B, everything in between there. It is including A, so it gets a bracket. It is including B, so B gets a bracket. Okay, so these are the notations that we're going to need, and if you'll notice back on that, on your guide here, that your domain and range are listed in that fashion. Okay, so let's get down to some numbers. If I have x is greater than -3, then I find -3, there's -3. If it's greater than, it's everything to the right. It does not include the -3. So our interval notation goes from -3, there is no boundary on the right, so it's going to go all the way to infinity. Okay. If I'm given the interval notation -infinity to 6, well, that means 6 is my upper limit. So I know I'm going to go to 6. And it is everything to the left of 6. It does not include the 6, so it has a parentheses. So in inequality notation, this would be x is less than 6. Okay. Here this means I am between -2 and 5. So -2 and 5. It's everything in between here. It is not including the -2, so that is a parentheses. It is including the 5, so that is a bracket. So in interval notation, it goes from -2 to 5. Negative 2 has a parentheses, and 5 has a bracket. Now, if I'm looking at the graph, this goes on forever and ever, so I'm starting over here at negative infinity, and I'm ending up at positive 2. There is a bracket here, and of course, negative infinity gets a parentheses. So this tells me that it is all the values that are less than or equal to 2. In interval notation, this tells me that my smallest value is 2 and my largest value is 7. So it's everything in between here. It does not include the 2. It does include the 7. So I know all my values, my x's, are between 2 and 7. It does not include the 2, so it's less than. It does include the 7, so it's less than or equal. Okay. All right, my boundary here is negative 4, and it goes to the right, so all of my x's are greater than negative 4. Since there is a parentheses, I leave it at greater than. If it was a bracket, I would put the equal sign in there. So in interval notation, this goes from negative 4 to infinity. And then lastly, if I have negative 4, it's between negative 4 and 7. So it's everything in here. It includes the negative 4, so it's a bracket. It includes the 7, so it is also a bracket. So in my interval notation, it's everything between negative 4 and 7, including those endpoints. Okay. So we're going to be looking at this. If you look at the next page, you'll see there are inequality notations on there, and wanted to make sure you understood those. Now you can make some little cryptic notes to yourself. If it's less than or greater than, then it's parentheses, less than or equal, greater than or equal is brackets, and negative infinity or infinity always get bracket or parentheses. So whatever notations you want to make to yourself about that. Okay. Okay, well, we're going to apply this to when we talk about piecewise functions. Now, piecewise function, it is a function that has a different rule for different pieces of the domain. So this graph that I've given you as an example shows the cost of purchasing a product. It has 3 pieces, each defined by a different linear equation. So this is like if you were to buy from between 0 and 20 of a product, you would pay $8 for each one. Okay, so if it's between 0 and 20, if it includes the 0 but doesn't include the 20, is going to follow this path. But then normally the more things you buy or the larger quantity that you buy, you get you get a cost break on it. So if you buy between 20 and 50, notice the slope has changed. You're only paying $6 per unit between 20 and 50. And if you buy 50 to 100, then you're only paying $4 for each one between 50 and 100. So this is kind of where you're going with this. And so now we are going to graph a couple of piecewise functions and just see how to do this. Okay, so on the left here, I'm given a piecewise function. It is defined in 3 different pieces. Okay. So you start at -4, go up to -1, and then it changes from -1 to 2, and then it changes again when x reaches 2. Now the thing you'll want to remember here is that on your graph, it's hard to put the parentheses. So if you have less than or greater than, you have an open circle. Less than or equal or greater than or equal, that circle is filled in to show that it includes that point. This shows that it comes directly up to that point, but it doesn't include it. Okay, now here's how I do it. I know I'm going to break this into different parts of the domain for different functions. So I know at -4, that is as far left as it goes. There is nothing over here. Then at -1, the graph is going to change. And at 2, the graph is going to change again. And it goes on to infinity. There's no limit on the left. So this is my smallest and my largest. Okay. And in between each, or in each of these 3 places, because this is just gone, it's going to follow a different rule. Well, these are lines, so we know how to graph a line. We need 2 points. So here's what I'm going to do on this. So I'm going to start with this function. And I'm just going to make myself a table of values. So I have x and y, which y is the same as f of x. But the function is x, so whatever x is, y is the same thing. And I'm going to use the 2 ends on that boundary. So I'm going to use -4. So if x is -4, y is -4. And I'm going to use -1. If x is -1, y is -1. Okay. Now when I'm plotting these points, I need to look at the inequality. This is going to be an open circle, and so is this. So I know at -4, -4, I have an open circle. I know at -1, -1, I also have an open circle. And then I'm just going to use my ruler and connect the dots. And this is how the function is defined if x is between -4 and -1. Okay. For my next function, once again, I'm just going to make a little table of values. And I'm going to use -1 and 2. Well, this is a horizontal line. And so f of x is equal, or y is equal to 2. It doesn't matter what the input is. Okay, so at -1, it includes it, so that's going to be a filled in circle. And on the other end, it's going to be an open circle. So I go from 2 to 2, and I connect my dots. So now my next function is -2x plus 4. Now when I do this, I'm going to start where x is 2. So that is -2 times 2 plus 4, which is 0. But I don't have a point on the right. So I know it's a line, I can select another point. So let's choose 4. Negative 2 times 4 plus 4 is negative 4. Or I can just use the slope to find another point. Okay. At negative 2, at 2, it is a closed circle. So the point 2, 0 is a closed circle. And then another point is going to be 4, negative 4. And I will draw a line, but it doesn't end. It goes on to infinity, so I'm going to have to draw a line with an arrow. Okay. All right. So let's look here, and it says find, I graph the function, let's find f of negative 2. What that means is find y if x is negative 2. Okay. Well, if x is negative 2, then I follow that down and I get the point negative 2, negative 2. So f of negative 2 is negative 2. Okay. On this next one, it means find y if x equals 2. So if I go to where x is equal to 2, notice I have an open circle here and a closed circle here. This means that this value, that this function does not exist at 2, only this one. So this is the point 2, 0. So f of 2 is equal to 0. Now, if I want to find the domain is all the values on which the function is defined. Okay, so this is where my interval notation is going to help. Well, it is defined, if I were to take a ruler and drag it across, it starts at negative 4. So I know my smallest value is negative 4. The open circle tells me that it is not included in there. As I go across, there is a y value for every x. Even though it jumps here and it jumps here, there is always a y value for every x. It is defined for every x. So this is going to go on up to infinity. Now you can also tell that from these inequalities. It goes from negative 4 to negative 1, negative 1 to 2, and then 2 on to infinity, so it encompasses everything. Okay, let's do one last one. All right, given g of x, it equals negative 3. That's a horizontal line between negative 5 and negative 2. Okay, so as I'm reading this, I know negative 5 is my smallest. So there is nothing to the left of this. It's just gone. Okay. Then I have a break at negative 2 where the function changes definition. And then I have a break at 1. And then I have a maximum, so my largest value is going to be 4. Okay. So my function is going to cover every value between my x's between -5 and 4. So I can go ahead and do my domain. My domain, this is going to be a closed circle, so it is going to go from -5. This is going to be an open circle, so it's going to go to 4, but it is not going to, oops, I'm sorry, it is not going to include that point. Okay, and we'll confirm that again. Okay, so on my first function, it says that g of x is equal to -3 in between -5 and -2. So if I do my xy table again, if I use -5 and -2, these are the two values that I'm going to use, my function is always -3. We already said this was a closed circle. This, of course, is an open circle. So at -5, the value of the function is -3 with a closed circle. At -2, it is the same value, but it is an open circle. And then I connect my dots. Okay. All right, then I'm going to do 2x plus 1. So for my table of values, I'm going to use my endpoints, -2 and +1. And of course, this is going to be a closed circle, and this is also going to be a closed circle. Oops, and 1, I'm sorry. So this is going to be 2 times -2 plus 1, which gives me -3. And for 1, 2 times 1 plus 1 gives me +3. So at 2, -3, I'm sorry, -2 is going to be -3. And 1 will be a +3, and it is, both of those are going to be closed circles. And then I connect my dots. And notice these two are connected. These two were not, and we'll talk about continuity at some other time. Okay, and for my last piece, at 1, I'm going to have an open circle, but I'm going to start with 1, and I'm going to end with 4. So -1 plus 4 is equal to 3. So I have the point 1, 3, and it's going to be an open circle. And then I have -4 plus 4, which is 0. So at 4, I'm going to have an open circle at 4, 0. And then I connect my dots. Okay. All right, so f of 0 means to find the y when x is 0. So that's going to be this point here, which is 0, 1. So f of 0 is 1. If I want to find f of 1, I have to figure out, it's at that where the functions change. So I need to figure out which function is the closed circle. This is going to be the point 1, 3. It is included in the 2x plus 1, so the value is 3. And now we can also see the domain here again. There is a y value for every x in between -5 and +4. Okay, the end.